Hi and welcome back to Free Science Lessons. By the end of this video, you should be able to describe what's meant by an isotope. You should then be able to describe how a mass spectrometer works. And finally, you should be able to analyse a mass spectrum. In the last topic, we saw how to use the atomic number and mass number to work out the numbers of protons, neutrons and electrons for atoms and for ions. Now, if you look at your periodic table, you'll see that the mass numbers are decimals, and that's due to the presence of isotopes. Isotopes are atoms of the same element with different numbers of neutrons and different masses. Now that is a key definition and you could be asked it in your exam, so you need to learn it. All of the isotopes of an element react in the same way, and that's because they all have the same electron configuration. I'm showing you here two isotopes of copper. Each isotope has got 29 protons, but the number of neutrons varies. This isotope has 34 neutrons, but this isotope has 36 neutrons. Now, one key idea you need to understand is abundance. The abundance tells us how common each isotope is. Around 69% of copper atoms are copper-63, and around 31% of copper atoms are copper-65. So the question is, how do we determine the mass number and abundance of isotopes? Well, to do that, we use a machine called a mass spectrometer, and you could be asked that in your exam. Now, if you're following the AQA specification, then you need to know the details of how the mass spectrometer works. There are several different types of mass spectrometer, but the one required for the AQA specification is called a time-of-flight mass spectrometer. In the first stage, we take a sample of the element that we're interested in, and we place this into the sample chamber. This sample contains all of the different isotopes of that element. The atoms then go through a process called ionization, and this converts all of the atoms into positive ions. These positive ions are now attracted to a negatively charged plate. This negative charge causes the ions to accelerate, and this increases the kinetic energy of the ions. Now, the key fact that you need to learn is that all of the ions with the same charge will have the same kinetic energy. For example, all of the ions with a single positive charge will have the same kinetic energy as each other. Once the ions pass through the negative plate, they stop accelerating and they drift down the chamber towards the detector. Now, the key idea you need to understand is that the ions drift down the chamber at different velocities, with the lighter ions moving faster than the heavier ions.